We have a sample problem. Again, we have a single acting air compressor with a clearance of 6%. So takes in air at atmospheric pressure and a temperature of 85 degrees Fahrenheit and discharge it at a pressure of 85 psi. So your air aid here stands for the absolute value. Now the air handled is 0.25 cubic feet per cycle, measured at the discharge pressure. Now if the compression is isentropic, so find the piston displacement per cycle, and B, the air horsepower compressor if the RPM is 750. So this is RPM, so I'm gonna rephrase this one. Okay, so but this is a 750 RPM. Okay, so I rephrase that. That is 750 RPM. Okay, so let's try to determine what is the given on the problem. Okay, we have here a single acting, so I'm gonna write here what are the given. So let's try to write that what are the given in the problem. So we have your given now. So initially we have your clearance, so that is 6%. Then we have your pressure 1, temperature 1, T1. So this is 85 degrees Fahrenheit. So I'm gonna add a 460 here to convert this one to an absolute value of Rankine. So this is 545 degree Rankine, and it has a discharge pressure of P sub 1.1. Sorry, this is not a P sub 1, but since it is a discharge pressure, so this will become your P sub 2. So this is your P sub 2, since it is stated in the problem it is a discharge. Okay, so that is 85 psi. So we have your A stands for your absolute. Okay, then we have here 0.25. So this is your air handled, so this is the air that is being displaced, so we can say this is your B2. Okay, so that will be 0.25 cubic feet per cycle. Then so you will notice here 0.25 cycle measured at the discharge pressure. Okay, so that will be the output. Now if the compression is isentropic, now find the displacement per cycle. We have also the horsepower and the given RPM of 750. So we have your N here, which is 750. So that will be revolution per minute. Now I will be drawing my PV diagram here. So I have my PV, so we have your pressure here and I have my volume here. So we need to plot this one in our PV diagram for those values. So you will notice here that the problem state here an atmospheric pressure. So we can say that we have your pressure 1, which is 14.7. So I'm gonna write that one, your pressure 1, is equal to your 14.7. This is psi absolute. So 14.7, so that stands for our atmospheric pressure. So I can write here 14.7. So I'm gonna give this one as a unit of psi. Psi absolute, and our volume here can be, so it does not mention so what type of okay, we can say this is for example, we can only assume, no, that is cubic feet per minute, so just to give it a volume flow rate. So later on we'll try to change if there is something not matching your our problem, no. And okay, so I have 14.7. So assumingly okay, wait, let's try to adjust this one. Okay, assumingly we have here our point 1. So to change this one, so this is our point 1 assumingly. Okay, then we have your P2, your discharge. So I'm gonna put here somewhere here, so 85. So I have me here my point 2, 85 psi absolute. So I'm gonna draw here the direction of the flow, so starting from 1 to 2, then we're having a straight line here, no, straight line from 2 to 3. So as your compressor deliver it to the discharge line, so we have here constant pressure. So I have here my point 3. Then finally I have my point 4 here. So we have my point 4 traveling from 3 to point 4. So this is will become our suction stroke starting from here, no? Then again drawing a straight line connecting that one. So I have my straight line here going back there, no? Okay, so let's try to put the label on our PV diagram so that we will be more familiar on this details. So we have here your volume flow rate B1 prime. So I have here my volume flow rate, or say this is the volume displaced from 3 to 1. Then I have here is my B1 volume flow rate, so starting from my 0 coordinates going to my point 1. So take note, the work is isentropic. Okay, so we have here your PV raised to K. So we have here constant. Now let's try to solve the question for letter A. So we're looking here a piston displacement. So that will be corresponds to the volume displaced. Okay. Now let's try to write your equation for your volume displaced. So we have your equation, which is your BD is equal to pi over 4. That will be D squared, then times your L, then your N. Now what we don't have here, we don't have the diameter, and we don't have the length of stroke, and we have only the RPM. So this is not a good candidate for the equation that we will be needing. So let's try another equation which is related to the volume displaced. So let's try using the relationship, no? So we have the volumetric efficiency, no? So that will be the ratio of your volume flow rate B1 prime divided by your volume displaced. Okay, so let's try to rewrite this one. So we can say that our volume displaced is equal to your V1 prime divided by the, sorry, this is the volumetric efficiency. Now, our equation for your volumetric efficiency, so that is, we have your volumetric efficiency, so that will be 1 plus C minus your C, then multiply by your P2 over P1. Okay, so this is raised to 1 over your K. Now we have your clearance given the problem, so that will be 6%, and we have your P2. So for the pressure to, so that is 85, and we have your P1, so this is can be solved now. So let's try to solve the volumetric efficiency. Substitute natin yung mga values here. So we have your volumetric efficiency, that will be 1 plus 0.06. That will be then minus 0.06. Then we shall multiply this one by your pressure 2. So this is 85 now. This is psi absolute. Then we shall be dividing this one into our value of pressure 1, which is 14.7 psi. So this is also absolute. Okay. Then raise this one to 1 over your K. So yung K dito sa problem, it does not specify, no? So yun minsan nagiging problema. So you must also memorize the value of K. So this is air. So usually the standard K of air for an isentropic process, if does na pag hindi siya binigay sa problem, so you can immediately substitute 1.4. So this is divided by 1.4. So we can compute your volumetric efficiency is equal to, so I have the value of 0. This is 842. Okay, so that will be the value of our volumetric efficiency. Now ang problem na lang natin is yung value ng B1 prime. Okay, so let's try to use PBMRT to solve the value of P1 prime. So I have your equation that will be P1, no? P1 prime, or say this is the same also, that will be P1, and have here B1 prime, which is equal to your mass 1 or mass prime, no? Mass flow rate prime. So since our mass flow rate here are equal, so by means of continuity from here and going here, we have an equal mass flow rate here, and we don't have the change of mass. Then multiply this one by your R, and we have your T1. Okay, so to get your B1 prime, so we have your mass flow rate prime times your R, then we have your T1 here, all over divided by your T1. And the problem here, what we don't have is the mass flow rate, okay, we don't have the mass flow rate here, the value for mass flow rate. Your R, we can use the constant of R. We have your temperature T1, so this 545, and we have your P1 also given. Now we don't have is the value of your mass flow rate. Let's try to get the value of your for this the mass flow rate at point 2. Okay, so let's try to do that one. So we have your P2, no, and we have here your V2. So volume flow rate at point 2, so which is equal to your mass flow rate prime, no, then that will be multiplied by your R, and we have your T2. Okay, since your mass flow rate dito sa point 1 and also the point 2 are equal. Okay, so let's try to write that one here. So our mass flow rate at mass flow rate prime at point 1 is equal to your mass flow rate at prime at point 2. Okay, so we can get the mass flow rate prime here, which is equal to your P2 volume 2, okay, divided by your R T2. Okay, since this one pressure 2 is given and B2 is given to the given to the problem, so that is 0.25 cubic feet per cycle, then T2 is yun lang ang wala tayo, but we have the value for your T1, so we can use the relationship, no? So we can say that we can write our equations here, so that will be your T2 T1, so that will be equal to your close parenthesis of this one, P2 P1. So we have this relationship of temperature and pressure, so this will be K minus 1 for polytropic process. Okay, no? So we can get the value of your T2. So let's rewrite our equation to get your T2. So we have your T2, that will be your T1, no? We multiply by your P ratio of your P to P1. Then this is raised to K minus 1 over your K. So let's try to substitute the values for this equation. So we have your T2 is equal to the value of your T1, which is 545, no? That will be degree Rankine. This is we multiply by your P2, so this is 85 psi absolute. Then let's try to divide this one by your P1, where the value of your P1 is 14.7, the psi absolute. Okay, then let's try to raise this one. We have your 1.4 for the value of K for your air, divided by your 1.4. Then finally, using your calculator, we can get the value. So we have the value of 899.78. So we can say this is now equal to 900 degree Rankine. So let's try to round off values here. Okay, so we have now your value of your T2, so we can directly substitute this one into our equation, so we can get your mass flow rate. So let's try to substitute it now. So we have your mass flow rate prime, so that will be equal to your P2, that will be 85. So this is psi, so let's express this one as foot-pound force per square inch. Then multiply it by the volume flow rate V2, so that will be 0.25 will be cubic feet per cycle. Okay, then all over divide this one by our value of your R, where your R for your air, so that will be 53.34. So this is 53.34. So with the units of that will be foot pound force, we here degree Rankine, then pound mass. Okay, close parenthesis on this one, then multiply by T2, which is 900 degree Rankine. So cancel natin units here. So pound mass, then the pound force cancel. Okay, so this is square inch. So okay, pound force will be cancelled. So we need to convert this one into square feet. So I have my conversion here. So I will write there. So this will be 12 inches, divided by your 1 feet or 1 foot. I'm gonna square this one so that we have one common units here. So this will be cancelled out. Your square inch will be cancelled out. So what is left is your 0.25. Your cubic feet, feet will be also cancelled out, and also our cubic feet here will be cancelled out. Okay, so what is left is pound mass per cycle, our units. So using your calculator, we have your mass flow rate prime is equal to, so I have a value of 0.63, 6374. You can express that one. So the unit here is pound mass per cycle. Okay, so we can substitute this one into our mass prime dito. Then our B1 prime is equal now to the mass prime, that will be 0.06374. So this will be pound mass per cycle. Okay, then I'm gonna multiply this one by your R, which is the R of air. It is 53.34. So this is foot pound force per pound mass degree Rankine. Then multiply this one by your T1. Our T1 is 85. 545. Sorry. This is 545 degree Rankine. Then this is all over, divided by your P1, which is 14.7. Okay, so this is 14.7 pound force per square inch. Okay, so again, check the units. So let's try to cancel this one and this one, so that will be pound force will be removed, and this one, your pound mass, also your Rankine also will be removed. Okay, will be cancelled out. Now our square inch, we need to convert this one again. So this is 12 inch, then divided by your 1 foot, then express this one to squared. Okay, so finally we have your answer for your B1 prime, which is equal to, so we have the value of volume flow rate. So this is 0.8753 or 8754. So this is this is volume flow rate. So this will be cubic meter. Okay, so the unit will be cubic feet, per cycle. So with the volume 1 prime already available, so we can substitute it into this equation for our volume displays. So let's try to do that one. So we have your volume displays. So this is now equal to your B1 prime divided by the volumetric efficiency. Since we have here 0.8754, that will be cubic feet per cycle. Okay. Then I'm gonna divide this one to the volumetric efficiency, which is 0.842. Okay. So finally we have the value of your volume displaced. So that is equivalent to 1.039. So we can use or 1.03, 1.039. So that will be cycle. This is cubic feet per cycle. So this will be cubic feet per. So this is one per cycle. Okay. Okay, so we have 1.039 cubic feet per second. So let's try to box the answer here. Okay, so that is for your letter A. Right here for the answer for your letter A answer. Okay. Now let's go to letter B. So we're looking for the compressor power, no? For letter B, so we have here, we can write here letter B. So we're looking for your power. So let's write the equation here. So we have your K for the power compressor isentropic will be P1. That will be V1 prime divided by 1 minus your K. So this is multiplied by your P sub 2, P sub 1. So raised to K minus 1 over your K minus 1. Okay. So checking the equations here, we need to, when we're going to substitute the values of here, so there's something we need to multiply with the B1 in order to achieve per minute cycle, okay, or cubic feet per minute per cycle. So let's try to do that one. So we have your volume per rate prime 1, so that will be 1.039. so this is cubic feet per cycle. So I'm gonna multiply this one, your 700 per RPM, so that will be 700 RPM, so rev per minute. So we have now your volume flow rate prime is equal to, okay, I forgot here, this is, I'm gonna change this one, so sorry about that. This is supposed to be our volume of 0.754, so sorry about that one. So I'm gonna erase this one, changing that one. So sorry about that. So we need to replacing this one for your B1 prime. Okay, so forgot that one. So let's try to multiply this one to get the value. So we have the value of 656. So this is 656.55. So we have the unit of cubic feet per minute. Okay. So we can compute or substitute this one to our work. So our work now will become your K with it be 1.4. So multiplying it by P1. So P2, we have your P1, so that will be 14.7. Now this is pound force per square inch. So I'm gonna convert this one. So we have 12 inches. So this is 1 feet. Then we have here squared. Okay. Then I'm gonna divide this one. No. Divide this one by your 1 minus your 1.4. Then multiply this by your close parenthesis. We have your P2, so that will be 85 psi absolute. Then divided by your P1, so that will be 14.7 psi absolute. Then let's try to raise the value here to, that will be 1.4 minus 1 divided by 1.4. Then this is minus 1. Then close parenthesis. So we have your work is equal to, again by checking the units, so you will notice here by means of cancellation. So I forgot to include our b1 prime, so including that one. So we have here that will be negative, no, that will be 166, then 555. Okay, that will be 0.65. So the units is foot, no, foot pound force per minute. Okay, so yun na may 1 na unit. Now we have conversion, so that will be 1 horsepower is divided by 33,000. So this is 33,000. If I'm not wrong, okay, so it's correct. Foot pound force per minute. Okay, so cancel your units. So finally we have your horsepower. So this is equate to, well, that is negative 95.95 horsepower. Okay, so that will be the answer for the problem. So okay, that's it. So that completes my solution. So that's it. So hope it will help you to fully understand. Okay, thank you.